unknown. Dia tak bagi you nilai S. Okay, how you want to conduct? Test the hypothesis that the population mean of the electrical current required for the bulb. Ini soalan example tadi yang pasal bulb tu. Okay. Dia suruh test the hypothesis that the population mean of the electrical current required for the bulb is at least 285 microamps. So what is the symbol for at least? What will be your H null and H1 here? So anyone?
Mu.
Dia masih lagi mu. And this mu is 285. So at least. What is the symbol for at least?
Larger. Greater than or equal.
Greater than or equal. Kalau ada equal, it will be H null. So here, greater than or equal. If your H null is greater than or equal, H1 will be?
Less.
Less than, correct. So left tail ke right tail? Left tail. Okay, and then you conduct this one using R. So masukkan dalam R. 5.2.5. 5.2.5. So 5.2.5, I got the p-value is equals to 0.0004. 0.0004. Okay, this one is less than alpha 0.05. Then you will reject H null. So reject this H null. Your conclusion, at alpha 0.05, the population mean of the electrical current required for the bulb is less than, kita terima yang ini, less than 285 microamps. Okay, right. Next example, when the sigma is not given but n less than 30. Okay, ingat tak kita akan guna apa? Masih lagi Z ke? Tak. Bila n less than 30, kita akan guna t-test. So, bila t-test ni, dia masih lagi guna command yang sama tadi. Coding yang sama untuk confidence interval. Sebab dia dah ada bagi siap-siap dah p-value. Okay. Less than, tengok kat sini, test the hypothesis that the population mean weight is less than. Okay, less than 5.2.6. Okay, ni saya masih lagi baca data baking powder tadi. Okay, the first one ni, t-test X adalah data kita, mu naught adalah 200. Kenapa 200? Sebab tadi population mean ni. Test the hypothesis that the population mean weight of a packet of baking powder is less than 200. Means that our mu naught is 200. So you put here 200. So if you do not put alternative here, here will be two tail. Okay. If alternative greater than, it will be right tail. If alternative less, it will be left tail. Clear tak? This one is two tail. This one is right tail. This one is left tail. Okay, so tadi dalam soalan dia kata less than kan? So it is a left tail. So left tail. Yang ini. So the p-value is 0.9983. So reject or accept H null? 0.9983.
Reject.
Accept.
Accept.
Do not reject H null sebab dia greater than alpha 0.05. So you boleh buat sendirilah solution dia. Okay, kalau saya tukar soalan jadi more than, kita guna yang ini. Oleh exercise. Okay, right? So now we move on to the proportion. Dah habis dah mu. So now we go to the pi. How we want to estimate pi using P? So using confidence interval, you will have the lower boundary and the upper boundary. So this one is the formula to find A. This one is the formula to find B. Satu je condition untuk proportion. Tak adalah greater than sample size ke tak ada. Non unknown pun tak ada. So for proportion, there's only one formula here. Okay. Tapi you kena tahu dekat sini how to find the P. P is equals to X over N. N is your sample size. X is the number of success. So number of success ni adalah proportion, the fraction. So look at later on how to find the P. Okay. Read the question. Estimate. So confidence interval. Population proportion. So estimate pi. So and you will find A and B. So from the question, the fraction of defective integrated circuit produced in a photolithography process is being studied. A random sample of 200 circuit is tested, revealing 13 defective. Daripada 200 circuit, 13 yang rosak. What is the symbol for this 13? X. Ini yang dikatakan number of success. Okay, so daripada sini, you can find P. P is equals to X over N. So X is equals to 13, N equals to 200. So you will get the P. Berapa nilai P ni? Calculator, someone? 13 over 200, 0
0.065.
0.065. Okay, so construct a 95% confidence interval on the fraction, proportion sama, of defective circuit produced by the process and comment. Okay, now we have the N, we have the X, we have the P. So let's do it in the R, 5.2.7. Example 5.2.7. You just put prop.test. Prop.test means that the proportion. Okay, prop.test. X ini adalah number of success. Our X is 13. Sekarang X ni bukan data, okay? X is the number of success. N is equals to 200, your sample size. Correct false ni dia adalah pasal continuity correction. Kita tak ada kata continuity correction, so it is false. So you just run this one. Dan you akan dapat the result. What is the P value? Sorry, kita nak buat confidence interval kan? So sini jawapan dia. Lower boundary is 0.0384 and the upper boundary is 0.1081. So we are 95% confident that the population proportion of defective circuit produced by the photolithography process lies between, so convert dia kepada percentage, fraction, proportion. Okay, jawapan akhir proportion always convert into percentage because we talk about proportion. Okay, this one, if you want to determine the sample size. So from the confidence interval, you can find also the sample size, right? So you just play around with the formula actually. Okay, so this is the formula to find the sample size. So this one you can go through on yourself, I think, because this one is the simple algebra. Alright. And then, so now tadi estimate pi using P. Now kita nak test. Hypothesis testing for pi. So the hypothesis testing for pi, dia punya H null, H1, notation dia sekarang adalah pi. Tadi tadi mu. So sekarang pi. So pi, so sebelah sini adalah pi naught. Pi naught ni adalah numbers lah. So pi naught ni dapat daripada mana? Daripada soalan. Okay. Step number 1. Step number 2, the only test adalah Z test. Dia tak ada T test. So for proportion, dia adalah Z test. Okay, look at the example. An attorney claims that, selalunya perkataan ni, testing ni, dia ada perkataan claim. Okay, an attorney claims that at least 25% of all lawyer advertise their service. So dia claim katakan sekurang-kurangnya 25% lawyer ni advertise their service. A sample, then dia ambil sample of 200 lawyers in a certain city showed that 63 use some form of advertising. At alpha 0.05, is there enough evidence to support the attorney's claim? So what will be your H null and H1? Ini pi,
By
ini pi. What is the value for this pi?
25.
25%. Convert into decimal places.
0.25.
0.25, 0.25. The symbol at least greater than and equal. Here is less than. So less than, this one is left tail. So ini adalah X. Masukkan dalam formula. Here are 5.2.9. Okay. So prop.test X kita tadi 63, N is 200, P 0.25. P ni bukan sample proportion. P in R coding is your population proportion. Your pi naught. P here is your pi naught. Pi naught is 0.25. Okay. Correct false ni adalah continuity correction. Always correct false. Alternative less. Apa maksud alternative less? Alternative less, this is the left tail. Okay, just run it. Okay, you will get the p value. P value is equals to 0.9831. So, this one is the solution. Ni saya dah bagi. X is the number of success. N is the number of trials, your sample size. P is the proportion in the null hypothesis, 0.25. Okay. So, alternate two-sided default, less untuk left tail, greater untuk right tail. So, you get your p value 0.9831. So, since p value 0.9831 greater than alpha 0.05, do not reject H null. So, you tak reject, you accept this one. So, pi is greater than equals to 0.25. So, at alpha 0.05, there is enough evidence to support attorney's claim that at least 25%. And the next one is your sigma square. So, for the sigma square, how to conduct confidence interval for the sigma square or sigma? So, this is the formula. We will use a chi-square distribution. Okay, this one is lower boundary. This one is upper boundary. Okay, look at the question. Estimate confidence interval. Population variance is sigma square. A random sample of 10 rulers, n is equals to 10, produced by a machine, give a set of data below. So you have this data. Find 95% confidence interval for the population variance of all the rulers produced by the machine. Okay. So dia bagi you n, dia bagi you data. Daripada data ni you boleh cari S square. So what did we do is we just put in into the R. Masukkan dalam R. Okay, library, read R. Saya guna data ruler tadi lah. Data tadi saya masukkan dalam Excel. Ruler. Saya masukkan dalam data Excel, ruler. Oops. Ini data saya. So I'll give you all this coding. Don't worry. And then, so you read the data. So V equals to variance of X. Means that the variance of your data, the sample variance. N equals to 10. So this is our V. And alright. So this one is the formula for the lower boundary and the upper boundary. So when you run this one, so this is data for the ruler. So when you run this, you will get the lower boundary and the upper boundary. Lower boundary is 0.0047 and the upper boundary is 0.0337. So we are 95% confident that the population variance of all the rulers produced by the machine lies between 0.0048 and 0.0337. Okay, ini data. Ini kita punya sample variance. Ini saya nak keluarkan dia punya variance dengan dia punya N. Okay, and then these are the formula for the lower boundary and the upper boundary. So you can ignore the message here, the warning message. You still get the lower boundary and the upper boundary. Okay. So the last one after you estimate the population variance is the hypothesis testing for population variance. So hypothesis testing for population variance. So tengok kat sini. Okay, so now H null, H1. The notation bukan lagi mu, bukan lagi pi. The notation now is sigma square. Sigma square. So sebelah sini sigma square, not value dia. And then this one is symbol. Okay, step number 1. Step number 2 is chi-square test. Ini sahaja dia punya formula for chi-square test. Right. Okay, look at the example. Testing. So, hypothesis testing for population variance. Listed are waiting times in minutes of customer at a bank. So, data-data customer at a bank. The management will open more teller windows if the standard deviation of waiting times is at least 0.9 minutes. Is there enough evidence to open more teller windows at alpha 0.01? Okay, give me the H null and H1. What is the H null?
Sigma.
The value of this sigma?
0.9. 0.9.
0.9. 0.9. Symbol?
Greater than or equal.
Greater than or equal.
H null greater than or equal.
H null greater than or equal. H1 will be less than. Okay. The management will open more teller windows if the standard deviation of waiting time is at least 0.9. So kat sini claim dia. Okay. Kalau you terima claim you ni, maksudnya dia kena open more teller windows. So now test. Test. Masukkan dalam coding kita.
Dia buat gila habis orang. Ajaklah dia biar.
Open. Okay. So now, the data just now I put in into time here. Time. Okay, data yang baru sekarang. So read the new data. So untuk variance ni, you kena ada package ini. ENV stats. Okay, download this ENV stat. Okay, and then you put here var test. Variance test. Time. Okay, alternative less. Kenapa? Sebab kita punya H1 less than sigma squared. Okay, sigma squared ni adalah kita punya sigma naught square. Tapi tadi dia bagi standard deviation. Tapi dalam coding dia mesti square. So, kita kena letak variance 0.9 square. Confidence level, dia nak alpha 0.01. Jadinya 0.99. So, you put here this one. Then you run it. Dan so you akan dapat P value dekat sini. P value is equals to 0.0506. So 0.0506 is greater than alpha 0.01. So dia guna alpha 0.01 tau. Kalau dibaca balik sini. Alpha 0.01. So if alpha 0.01, confidence level 99%. So confidence level 99%, ubah dekat sini 0.99. So you dapat P value 0.0506. So since P value 0506 greater than alpha 0.01, do not reject H null. So sekarang ni dia kata do not reject H null. Tak reject pun H null ni. Kita accept this H null. What will be your conclusion? So our conclusion at alpha 0.05, dia akan open more tailor windows. The management will open more tailor windows. So betul lah dia punya claim ni. Dah habis. Habis dah. So we have covered the normality. We have covered the confidence interval for one population mean, hypothesis one population mean, confidence interval one